Question 1. As a result of a leak in a commercial reach-in freezer using R404, a technician is to oust and evacuated the system and prepared to recharge it. Before proceeding, he begins inspecting the recovery cylinder and notes that the cylinder is not labeled and has visible surface rust. What is the most appropriate action is to oust and should take before continuing the job? A. Use the cylinder since the recovery process has already begun. B. Transfer the refrigerant into the cylinder anyway, then label it afterward. C. Stop and replace the cylinder with a properly certified and labeled one. D. Clean off the rust to mark the cylinder with a permanent marker. Answer. Correct answer. C. Explanation. EPA regulations under Section 608 prohibit the use of unlabeled or compromised recovery cylinders. A rusty, unmarked cylinder presents a safety and regulatory hazard. According to EPA 40 CFR Part 82, Subpart F, all recovery cylinders must be Department of Transportation approved, color-coded, and clearly labeled to identify contents. Continuing with a cylinder risks contamination and legal penalties. Cleaning or labeling the cylinder post-factum does not meet compliance or safety standards. Question 2. During the process of commissioning a variable air volume valve system in a new office building, technician Garcia observes hot and cold spots in different zones despite all valve boxes receiving proper voltage and airflow. Which of the following is the most likely underlying cause? A. Incorrectly sized valve boxes. B. Faulty actuator motors on the air dampers. C. Poor duct static pressure balancing. D. Undersized rooftop unit cooling capacity. Answer. Correct answer. C. Explanation. Uneven temperatures across valve zones with working actuators and correct sizing typically point to improper static pressure regulation. According to ASHRAE Standard 111, air balancing is critical for uniform zone performance. Poor static pressure balancing leads to zones being over or underserved regardless of valve function, while actuator failure or sizing could contribute. The systemic imbalance suggests a duct pressure issue affecting all zones, not isolated components. Question 3. In light of recent developments in building humidity control, Mr. Patel is asked to review an air handler's ability to maintain 50% RH in lab. He measures dry bulb temperature of 75 degrees and wet bulb temperature of 62 degrees. Using the psychrometric chart, what should he conclude about the moisture content? A. The air is too humid to meet requirements. B. The dew point is too low for condensation to occur. C. The moisture content is appropriate for 50% RH. D. The sensible heat ratio is exceeding latent capacity. Answer. Correct answer. A. Explanation. Dry bulb of 75 degrees and wet bulb of 62 degrees. Place the air above 50% RH on the psychrometric chart. Closer to 60%. According to ASHRAE Fundamentals Handbook, RH above 50% in sensitive areas like labs can promote microbial growth and reduce air quality. Mr. Patel should consider enhancing latent cooling via reheat or adjusting airflow conditions. Dew point and SHR concerns as secondary RH already exceed specification. Question 4. When considering low-voltage transformer selection for a large HVAC system with multiple zones, Mr. Lawson installs a 24th transformer rated at 40V. After activation, he finds intermittent operation across multiple thermostats. What is the best explanation? A. Thermostats are wired incorrectly. B. Transformer does not have enough VAR capacity. C. System voltage exceeds 24V. D. Incorrect phase to ground wiring. Answer. Correct answer. B. Explanation. Transformer voltam rating must match or exceed total load demand from all connected controls. Each thermostat and damper motor draws current. Per NEC Article 725 and manufacturer's specs exceeding the transformer's VAR leads to overloads and erratic control. Intermittent operation indicates marginal capacity or thermal protection kicking in. Larger VAR-rated transformer is necessary to maintain stable operation. Question 5. To illustrate this point, Newman was diagnosing a three-phase condenser fan motor that had tripped its overload several times. All three line voltages read within 2% of each other. The motor windings tested within manufacturer specs, which is the most likely root cause of repeated tripping. A. Short cycling due to a faulty pressure switch. B. Phase rotation in the wrong direction. C. Fan blade is imbalanced or obstructed. D. Undersized contactor for the motor load. Answer. Correct answer. C. Explanation. While voltage and windings are fine, mechanical restriction is a likely cause of overload tripping. An unbalanced or obstructed fan blade increases current draw under load. NEC 430 and NEMA MG1 recommend checking both electrical and mechanical loads before replacing components. Phase rotation or contactor issues would cause immediate, not progressive, failures. Short cycling causes compressor, fan motor overload typically. Question 6. The underlying principle of the second law of thermodynamics implies that heat energy will naturally flow in which direction? A. From high pressure to low pressure. B. From cooler objects to warmer ones. C. From warmer objects to cooler ones. D. From areas of low entropy to high entropy. Answer. Correct answer. C. Explanation. The second law of thermodynamics states that heat moves spontaneously from higher to lower temperatures, while entropy does increase in natural processes. HVAC applications primarily follow this principle in heat transfer. Heat pumps require work input to reverse this natural flow. Pressure is not the direct driving factor in heat flow. Temperature gradient is. ASHRAE and DOE training materials emphasize this as core concept for system design. Question 7. Given the circumstances, technician Mr. Raymond is tasked with installing a rooftop URU on a commercial building. The original duct design calls for a supply duct with 590-degree elbows and 80 feet of linear duct. To maintain proper airflow, what should Mr. Raymond consider during installation? A. Replace rigid duct with flexible duct for better maneuverability. B. Increase the duct diameter to reduce static pressure losses. C. Eliminate return duct to reduce total resistance. D. Use thinner insulation to preserve inner diameter. Answer. Correct answer. B. Explanation. Each 90-degree elbow adds equivalent length due to turbulence and friction loss. According to a CAM manual D, this increases total equivalent duct length and static pressure potentially exceeding fan capability. Increasing duct diameter reduces friction per foot, maintaining airflow. Flexible ducts typically increase resistance. Removing the return duct violates system balance and efficiency. Thinner insulation compromise thermal control without affecting inner flow much. Question 8. A demonstrated by technician is trying a high-efficiency residential heat pump was evacuated down to 450 microns. However, when isolating the system, the vacuum level rises to 1100 microns and stabilizes. What does this indicate? A. The system is adequately evacuated. B. There is a leak or moisture remaining in the system. C. The vacuum gauge is inaccurate. D. The oil in the compressor is reacting to refrigerant. Answer. Correct answer. B. Explanation. A rise from 450 to 1100 microns during isolation implies outgassing from moisture or a leak. According to EPA and NEVA guidelines, vacuum must hold below 500 microns to ensure system dryness and tightness. If the pressure rises and stabilizes above 1000, suspect either non-condensables or moisture evaporating. The vacuum gauge is reading accurately. Test. Compressor oil effects are not significant at this vacuum level. Question 9. Taking into account a walk-in freezer using R440 and operating at -10°, Vista Silva notices high superheat at the evaporator and sporadic compressor cycling. What component is most likely malfunctioning? A. Thermostatic expansion valve sensing bulb. B. Crankcase heater. C. Liquid line solenoid valve. D. Suction accumulator. Answer. Correct answer. A. Explanation. High superheat at the evaporator indicates underfeeding of refrigerant, commonly caused by a faulty or mispositioned TXB sensing bulb. Sporadic cycling may result from rapid pressure or temperature fluctuations. EPA regulations and manufacturer diagnostics prioritize proper sensing bulb contact and positioning. A faulty crankcase heater or accumulator won't cause superheat anomalies. Solenoid valves impact flow, but less so superheat stability unless completely stuck shut. Question 10. Throughout the course of a school HVAC assessment is Brooks finds co-concentrations in several classrooms averaging 1200 ppm during occupied hours. What conclusion is most accurate and what should be recommended? A. Ventilation rates meet ASHRAE standards. B. Co-levels are acceptable due to occupant load. C. Fresh air ventilation needs to be increased. D. Co-levels are irrelevant to indoor air quality. Answer. Correct answer, C. Explanation. ASHRAE Standard 62.1 recommends indoor co-levels stay below 1000 ppm for adequate ventilation. At 1200 ppm, ventilation is insufficient, contributing to occupant discomfort and cognitive decline. What CO is non-toxic at this level? It indicates poor dilution of indoor contaminants. Occupant load matters but doesn't justify exceeding limits. CO's widely accepted IAC benchmark. Ignoring it undermines system design intent. Question 11. When analyzing a residential air handler, Mr. Jenkins noted that the unit was delivering cool air, but the home experienced uneven temperatures, particularly in upper rooms. Supply registers in those rooms showed air temperatures consistent with the coil's output. What underlying issue is most likely contributing to the discomfort? A. Poor insulation in the attic ductwork. B. Refrigerant undercharge affecting coil capacity. C. Thermostat location near return grill. D. Blocked condensate drain reducing airflow. Answer. Correct answer, A. Explanation. Heat gain through poorly insulated ductwork, especially in hot attic spaces, can offset the cooling effect delivered by the coil. According to Manual D and ASHRAE 90.1, ducts in unconditioned spaces must be insulated to prevent significant thermal loss or gain. If the supply air temperature is consistent but upper rooms are warm, it's likely that duct heat gain is occurring. Refrigerant levels and thermostat placement wouldn't selectively affect only upper rooms. Question 12. In terms of refrigerant behavior during phase changes, which of the following best describes the role of latent heat within the vapor compression refrigeration cycle? A. It increases the temperature of vaporized refrigerant in the compressor. B. It raises the pressure of the refrigerant entering the condenser. C. It allows heat absorption or rejection without a temperature change. D. It prevents the refrigerant from condensing at low ambient temperatures. Answer. Correct answer, C. Explanation. Latent heat is absorbed or rejected during phase changes, such as evaporation or condensation, without changing temperature. This concept is central to refrigeration, where refrigerants absorb heat during evaporation and reject it during condensation. The temperature remains stable during this transition. This aligns with principles from the laws of thermodynamics and is outlined in HVAC Fundamentals and ASHRAE Handbook. The other options confuse pressure and temperature with phase change energy transfer. Question 13. From a practical standpoint, Domings is called to investigate a packaged rooftop unit that trips on high pressure limit during hot afternoons. The condenser coil appears clean and airflow across the evaporator is within spec. What is the most logical issue to investigate next? A. Undersized return duct creating high static pressure. B. Condenser fan not operating at full speed. C. Faulty low pressure switch. D. Dirty evaporator coil causing low suction pressure. Answer. Correct answer, B. Explanation. High ambient temperature increases condenser head pressure. If the condenser fan is not running at correct speed or is failing intermittently, it cannot reject heat effectively, leading to high pressure limit trips. This is consistent with ANSI ASHRAE 15 guidelines on pressure control and condenser function. A low pressure switch or return duct would not directly cause high pressure trips under proper airflow conditions. An evaporator would lower suction, not raise discharge pressure. Question 14. The primary reason for high energy bills in a residential home with a functioning central air system and correct refrigerant charge was traced to duct leakage. What is the most appropriate solution to address this problem? A. Replace the ductwork with rigid duct only. B. Install booster fans in longer duct runs. C. Seal the ducts using mastic or aerosol-based methods. D. Close off and use supply registers. Answer. Correct answer, C. Explanation. Duct leakage can account for 2030% of energy losses in HVAC systems per Energy Star and DOE studies. Sealing ducts with a 181 approved mastic or aerosol systems like aerosol is the recommended solution. Replacing ductwork is costly and not always necessary. Booster fans may compensate for pressure loss but won't stop leakage. Closing registers create static imbalances and can stress the blower motor. Sealing is both efficient and co-compliant. Question 15. To better understand airflow distribution in a commercial system, Mr. Alvarez consults the mechanical plans, which include duct sizes, flow arrows, and diffusers. However, airflow performance is not aligning with the design. What additional documents should Mr. Alvarez refer to? A. The building's electrical single-line diagram. B. The equipment submittal data sheets. C. The test and balance tab report. D. The structural plan for the building. Answer. Correct answer. C. Explanation. The tab report documents actual airflow readings, pressures, and system performance, which is essential for comparing design intent versus real operation. It is prepared after installation by certified professionals following NEB HVACR standards. Submittals and electrical diagrams don't contain operational airflow data. Structural plans relate to support and integrity but not HVAC function. Without data, diagnosing deviations from airflow design is speculative. Question 16. Examining the consequences of skipping lockout-tagout LOTO during HVAC services. The sinker attempts to test a high-voltage motor without isolating power. He receives a mild shock but is otherwise unharmed. What legal and professional standard has been violated? A. EPA Clean Air Act Section 608. B. OSHA 1910.147 Control of Hazardous Energy. C. ASHRAE Standard 15. Mechanical Equipment Rooms. D. NFPA 90. Installation of HVAC systems. Answer. Correct answer. B. Explanation. OSHA 1910.147 mandates LOTO procedures to protect personnel during servicing of equipment with hazardous energy. Failure to isolate power, even if no injury occurs, is a violation. The shock indicates improper lockout. EPA 608 relates to refrigerant handling. ASHRAE 15 and NFPA 90 cover mechanical room safety and fire protection, respectively, not electrical servicing safety. LOTO violations are among the most cited OSHA infractions in HVAC. Question 17. By evaluating a two-pipe hydronic heating system, Kim observes that some radiators remain cold even when the circulator pump is running and system pressure is within normal range. What is the most likely cause of this issue? A. Air trapped in portions of the piping. B. Incorrect thermostat location. C. Excessive system head due to undersized pump. D. A failed aquastat sensor. Answer. Correct answer. A. Explanation. Air trapped in radiators or piping can block water flow, resulting in uneven heating even if pressure appears normal. Proper air venting using automatic or manual air bleeders is necessary per hydronic system best practices. Incorrect thermostat location may affect cycling but won't isolate heating to specific zones. Pump sizing affects the whole system, not just selective radiators. Aquastats control boiler firing, not circulation directly. Question 18. With the advent of higher performance insulation and fenestration technologies, ISTA is recalculating the cooling load of a home using manual J. The previous load was 3 tons, but the new estimate is 2.2 tons, which action aligns with the CAM Manual S guidelines. A. Install the original 3-ton system to avoid undersizing. B. Use a 2-ton system with a variable speed blower. C. Stick with the 3-ton unit for better humidity control. D. Size the unit strictly to the calculated 2.2-ton load. Answer. Correct answer. B. Explanation. Manual S advises selecting equipment closest to the manual J load while considering sensible and latent capacity. A 2-ton unit with a variable speed blower matches performance to load more precisely, improving dehumidification and efficiency. Oversizing risks short cycling and poor humidity control. Strictly installing. A 2.2-ton system is not feasible since units are not made in fractional sizes. Manual S encourages capacity modulation when exact match isn't possible. Question 19. From multiple perspectives, how does a restriction in the liquid line, such as partially blocked filter dryer, Impact the refrigeration cycle. A. Causes low suction pressure and low superheat. B. Leads to high discharge pressure and high subcooling. C. Results in high superheat and low suction pressure. D. Increases suction pressure and raises evaporator temperature. Answer. Correct answer. C. Explanation. A liquid line restriction reduces refrigerant flow to the evaporator, starving it and causing high superheat and low suction pressure. The compressor works harder due to reduced cooling effect. High discharge pressure may not occur unless other faults exist. Subcooling typically increases before the restriction but doesn't compensate for poor evaporation. This aligns with diagnostics taught in EPA section Roman industry troubleshooting charts. Question 20. The growing trend in modern construction has led to tighter building envelopes. Stephenson is evaluating a new home with ERV and sealed insulation. Co-levels are within range but VOC concentrations are high. What's the best remediation strategy? They install additional carbon monoxide detectors. B. Increase ERV ventilation exchange rate. C. Use dehumidifiers to reduce mold risk. D. Upgrade MERV rating of return filters. Answer. Correct answer. B. Explanation. Tight construction reduces natural infiltration, trapping VOCs from furniture, paints, and finishes. While co-levels may be acceptable, VOCs require adequate air exchange. Increasing the ERV rate dilutes contaminants while maintaining energy efficiency. MERV filters don't capture VOCs. Code detectors and dehumidifiers address other issues but not airborne chemicals. Per ASHRAE 62.2, ventilation. Count for pollutant sources, not just occupancy. Question 21. In the modern context of smart HVAC systems, Earlwood was troubleshooting a BACnet-enabled DEC system where valve dampers were intermittently failing to modulate properly. Network diagnostics showed no packet loss, and the DEC controllers were receiving set points. What is the most likely cause? A. Damper actuators wired with incorrect polarity. B. Faulty control algorithm logic in the supervisory controller. C. Static pressure sensor installed upstream of valves. D. Loss of network synchronization with building automation server. Answer. Correct answer. B. Explanation. When communication is stable but control behavior is erratic, the issue often lies in incorrect logic programming or flawed PID tuning in the supervisor DDC. BACnet systems rely heavily on proper control sequencing. ASHRAE Guideline 13 and 36 outline best practices for control logic and zoning behavior. Faulty logic could cause improper damper modulation despite accurate inputs. Wiring, sensor position, and sync loss typically result in complete failure, not modulation errors. Question 22. Among the various pressure readings obtained on a low-pressure centrifugal chiller using R1233s, Keller notices the evaporator pressure is significantly below atmospheric pressure, yet the chilled water temperature is stable. What does this indicate? A. The system is overcharged with refrigerant. B. Normal operating conditions for low-pressure refrigerants. C. A leak has introduced air into the evaporator. D. Expansion valve is stuck closed, starving the evaporator. Answer. Correct answer. B. Explanation. Low-pressure chillers using refrigerants like R123 or R1233s normally operate below atmospheric pressure in the evaporator. This design enhances efficiency and allows evaporation at lower temperatures. According to ASHRAE 15 and EPA Section 608 Type Roman guidelines, subatmospheric pressure is expected. Stable chilled water temperatures confirm that the system is operating correctly. A leak would typically cause temperature rise, and a stuck expansion valve would alter superheat and water temp. Question 23. To illustrate this point, Mr. Dorsey is tasked with brazing a refrigerant line in a high-rise commercial building. He opts to use a nitrogen purge during the process. What is the primary reason for this procedure? A. Reduce chances of refrigerant migration during future servicing. B. Prevent formation of copper oxides inside the tubing. C. Minimize the boiling point of the brazing alloy. D. Lower the pressure inside the pipe during joint heating. Answer. Correct answer. B. Explanation. Using nitrogen purge during brazing displaces oxygen, preventing oxidation inside the copper tubing. Oxide flakes can clog metering devices and restrict flow. This is A best practice endorsed by ASES and outlined in many manufacturer specifications. It has no effect on brazing alloy temperature or system pressure. While it doesn't directly prevent refrigerant migration, it ensures internal cleanliness vital for long-term performance and reliability. Question 24. A key distinction between power and energy is vital for HVAC efficiency calculations. Which of the following best describes the difference between the two in an HVAC context? A. Power is work done, and energy is the rate of doing work. B. Power is stored capacity, while energy is instantaneous demand. C. Energy is the ability to do work, and power is the rate at which work is done. D. Energy and power are interchangeable in HVAC load calculations. Answer. Correct answer. C. Explanation. Energy is the total quantity of work done, measured in joules or betas. Power is the rate of doing that work, measured in watts or horsepower. HVAC systems consume energy over time, but equipment sizing is based on power demand. Understanding this distinction is essential when evaluating efficiency. G. E equals BU watts. ASHRAE and DOE definitions consistently reinforce this differentiation. Question 25. Upon closer examination, Mr. Bradley finds that a heat pump installed in a single-family home operates in heating mode but delivers lukewarm air even though the compressor and outdoor fan run continuously. What is the most likely issue? A. Thermostat is set to emergency heat mode. B. Reversing valve is stuck in cooling position. C. Outdoor coil is covered in debris. D. Indoor fan motor is operating at too high a speed. Answer. Correct answer. B. Explanation. If the heat pump delivers cool air while in heating mode, the reversing valve may be stuck in the cooling position. In this case, the system is rejecting heat outside rather than transferring it indoors. This is a common fault and matches symptoms outlined in NATE and ASES diagnostics. The dirty coil or fan speed mismatch would reduce efficiency but not reverse the heating effect. Emergency mode typically activates resistive, not cooling. Question 26. Looking at the data on electrical diagnostics, Mr. Yates is measuring inrush current on a scroll compressor using a clam meter with a peak capture function. Why is it important to measure inrush current rather than just running amperage? A. Running current determines compressor lifespan. B. Inrush determines system cooling capacity. C. Inrush may cause break trips even if running current is normal. D. Running amperage will always be lower than manufacturer spec. Answer. Correct answer. C. Explanation. Inrush current is the surge drawn when a motor starts and can be 5-7 times higher than running current. Breakers may trip during inrush if not rated properly or if start assist components fail. Measuring only running amps may miss these transient but critical conditions. NEC Article 430 and manufacturer specifications require understanding both to evaluate starting performance. Running relates to efficiency, but inrush ensures reliable startup. Question 27. Considering the evidence is Santana is evaluating a variable refrigerant flow VRF system in a multi-zone commercial facility. Some zones do not reach set point in cooling mode. What is a common ERS-specific issue that can cause this? A. Condensate line is clogged at the air handlers. B. Outdoor unit refrigerant charge is excessive. C. Control board firmware mismatch across indoor units. D. Simultaneous heating and cooling mode conflict. Answer. Correct answer. D. Explanation. ERF systems can simultaneously heat and cool different zones using shared refrigerant. If the system isn't configured properly, one zone's call for heating can reduce refrigerant availability for another zone's cooling. This control conflict is documented in manufacturer service manuals and ASHRAE ERF guides. Firmware mismatches affect communication but less commonly performance. Overcharge and condensate issues don't typically cause cooling imbalance. Question 20. The effectiveness of preventive maintenance was questioned by Mr. Doyle's client, who was unaware of the need for regular evaporator coil cleaning in their mini-split system. What is the most compelling technical reason for this maintenance task? A. Prevent refrigerant leaks caused by corrosion. B. Maintain correct superheat and airflow. C. Avoid compressor oil migration. D. Protect the blower motor from high static pressure. Answer. Correct answer. B. Explanation. Dirty evaporator coils reduce heat transfer, leading to high superheat, low suction pressure, and inefficient operation. Cool. Cleanliness ensures proper airflow and refrigerant evaporation. According to accountant Ari, reduced coil efficiency can cause long-term system degradation, corrosion or migration, or static pressure issues as secondary or indirect effects. Regular cleaning is low-cost preventive action with impact on performance. Question 29. Historically speaking, HVAC systems have relied on high ventilation rates to ensure acceptable indoor air quality. However, in tightly sealed buildings, what strategy provides the best energy-efficient air control? A continuous ventilation with constant speed fans. B. Manual window opening policies during the day. C. Demand-controlled ventilation with co-sensors. D. RC lights in all return ducts. Answer. Correct answer. C. Explanation. Demand-controlled ventilation (DCV) adjusts outside air intake based on occupancy measured via co-sensors, minimizing overventilation and energy waste. ASHRAE 62.1 supports DCV as an effective IACN efficiency method. Manual windows introduce uncontrolled variables, and constant speed fans don't respond to dynamic conditions. RC lights help reduce pathogens but do not regulate ventilation. DCV balances health and energy conservation in modern HVAC design. Question 30. In comparison with sensible heat, how does latent heat affect air temperature readings? A. Latent heat raises dry bulb temperature without changing humidity. B. Latent heat causes a temperature drop during dehumidification. C. Latent heat transfers moisture without changing dry bulb temperature. D. Latent heat is only relevant in heating systems, not cooling. Answer. Correct answer. C. Explanation. Latent heat is the energy involved in changing a substance's state without altering its temperature. In HVAC, it's primarily the energy required to remove or add moisture from air. This doesn't affect the dry bulb temperature even though total energy changes. Sensible heat changes temperature directly. Understanding this distinction is key to psychrometrics as detailed in ASHRAE Fundamentals and the CAM Manual J. Misunderstanding this can result in improper load calculations.